Good afternoon, everyone. Would it surprise you if I told you that between 2021 and 2023, over 1,700 new data analysts, data engineers, and data scientists were advertised through NHS jobs? If we expand this out to all NHS vacancies, would it surprise you even further to learn that over 1 million unique vacancies were advertised on their platform? With the NHS workforce constantly changing, is it any wonder why initiatives like the National Competency Framework have been introduced to try and bring some order to the seemingly endless expanse that is the NHS workforce? So today, I'm going to talk about a bit of the work that I've done and how it could maybe be used to complement initiatives like the National Competency Framework. So the first thing that I have to do is introduce the National Competency Framework. Now, I'm not going to go into too much detail because yesterday Sarah Blundell gave an amazing talk on it, and if you want more details, I highly recommend you catch up on that. But back in 2021, a report was published that projected that in order to meet demand, the NHS digital workforce would have to increase by 69% in the space of a decade. And at around the same time, the idea for the National Competency Framework was born, with the goal to try and standardise and professionalise the data professional roles across the NHS. Now that's where I come in. First and foremost, I'm a data scientist. So the NCF is directly targeted towards my job. But I'm also a data scientist at the NHS Business Services Authority. And for those of you who don't know us, among the services that we manage, including prescriptions and pensions, we also manage the NHS Jobs Platform, which gives us access to loads of great data, including job description texts. So we felt that we were in a unique position where we could take historical job description text for data professionals, we could extract out technical skills for them, and then compare the vacancies to get a baseline of variability in the recruitment of data professionals before the implementation of the NCF. So in order to reach that target, there were two main challenges that we faced. And the first was extracting out technical skills from text. Now, suppose I gave you that piece of text and I asked you, find the technical skills in it. It might take you a couple of minutes to read through it, and you might highlight the following as being related to technical skills or capabilities. It then might take you another couple of minutes just to record those. But what if I asked you to do this for all 10 pages of this particular job description? What if I asked you to do it for all 1,700 data professional roles? You'd probably laugh me out the room. So instead, we need a programmatic way of extracting out the skills. And that's exactly what we did. In-house, we created a dictionary of technical skills that we thought should appear within data professional roles. Essentially, a lookup. Then, reading in the job description texts into something like R, we can then perform a string matching approach to see whether any of the skills within our dictionary appeared within the text. And if it did at any point, we would class that as being one of the technical requirements for that particular role. Great. We've now got an approach where we can identify technical skills for each vacancy. But how exactly do we go about comparing them? Suppose we had the 3 jobs on screen and we've extracted out their technical skills. How can we say that job 1 or vacancy 1 is more similar to vacancy 3 than it is to vacancy 2 in terms of these technical skills? Well, there's lots of different ways we could go about doing this, but the way we took it was to use the Jacquard similarity. And basically, what the Jacquard similarity does is it counts how many skills overlap between the 2 roles relative to the total number of unique skills between the 2 roles. So in this example, 1 skill overlaps between vacancy 1 and vacancy 2. That's equal. but there are 6 unique skills between them. So this would get a similarity score of 1/6. We repeat this for all pairs of jobs, and we can construct something called a similarity matrix, where each number in that matrix corresponds to the similarity between a pair of jobs. Perfect. We've solved that challenge. But who can actually look at a similarity matrix and tell me patterns that appear? Which jobs are most similar? It's not too bad when you've only got 3 jobs, but what if we upped it to 50 jobs? Who can honestly tell me they can look at this matrix and tell me which jobs are most similar and which ones are most dissimilar? If it were me and I was asked to do that, I'd probably have a bit of a meltdown. So instead, we need to have an additional step here. What we need to do is to be able to take this matrix and reduce its dimensionality into 2 dimensions, so 2 numbers per vacancy that we can easily plot. But the key challenge here is that we have to make sure that we preserve the similarities and dissimilarities between vacancies. We can't just use any method. Well, thankfully, a method already exists that allows us to do this, and it's called multidimensional scaling. So we can take the matrix and project it down into a 2D scatter and compare which vacancies are most similar and most dissimilar. So let's jump into the real-world results. So on screen, I have the results for the data scientists. Again, each point here is a unique vacancy. And what we can see straight away is that there's variability in the recruiting criteria for data scientists. If it was exactly the same, this plot would look really boring. It'd be a single point right in the middle because everything was the same. So straight away, because that's not the case, it suggests that there are differences. Yes, we have pockets of very similar roles, like in the dark blue, but there are also some outliers there, like the 2 light blue points at the top. Now, as I mentioned, I'm a data scientist, and my job description was actually part of this data set. So I was really interested to see where my technical skills compared to others across the NHS. And I was pleased to find that it was in this dark blue group, so suggesting that the requirements for my role are not too dissimilar from others in the NHS. Moving on to data engineers, we see a similar story. Yes, there's variability and areas of similar roles, but interestingly here is that we have 3 pockets of locally similar jobs that are globally dissimilar. Actually, the reason behind this is quite interesting. One of these pockets is simply because it's the same job being advertised multiple times from the same organization. And the other 2 are again from the same recruiting organization, but slightly different job titles or job levels. So I think one of them is for a junior data engineer and the other for a senior data engineer. And finally, for the data analysts, a lot more points here because data analysts are a more common role. But it's interesting to see that, again, that there is variability in the recruitment criteria. So this has been a very whirlwind tour of the work and the results. And I know what you're thinking, I want to learn more. Well, good news for you. We've summarized all of this work as a blog. It's openly available online on GitHub, and you can follow the link on screen to get access to it. And we're supposed to have a video playing, but essentially it's an interactive blog where we have the dictionary of technical skills that we've derived. You can go ahead and download them if you want. We also have the images, so the plots. And those plots, let me just go back. Those plots allow us to hover over each point. We can see who the recruiting organization is. We can see what skills we're being asked for. We've even included the NHS pay band, so you get a little bit of additional information. And again, all of that is available to download if you wanted to take it home and look at it in more detail. In future, we hope to repeat this analysis on more recent data. And that way, we can compare the impact the NCF has had. We can see the variability before it was introduced and hopefully the reduction in variability after it's been introduced. We hope to refine the skill extraction step using Amazon Bedrock and their generative AI models, where we'll ask LLMs not only to identify the skills, but also extract them for us. And finally, we hope to expand this beyond just data professionals and look at the wider NHS to gauge what level of data literacy there is for everybody. So with that, I'm going to conclude, but leave you with a simple question. And that is, what kind of things would you like us to do with the NHS jobs data? I've given one example today, but there's literally hundreds of different options we could go with. So I'd be happy to hear your thoughts and possibly collaborate with you in the future. Thank you.
Thank you very much, Thomas.
Thank you.
Gosh, anything that simplifies and also standardises has got to be good in this range, hasn't it?
Absolutely.
17 pages of a job description. My goodness me, what's happened? And did you see that long list of all the essential criteria? Who on earth meets that? Nobody, I'm absolutely sure. So yes, well done. Great piece of work. Has anybody got any questions for Thomas? In the old-fashioned kind of way of putting your hand up and me handing you a mic. Oh, somebody right at the back. Can you shout? Because save me running.
Yes, multi-dimensional scaling.
Could you repeat the question here?
So the question was, what method did we use to reduce the dimensionality? And it's called multi-dimensional scaling. So it's very similar to principal component analysis that you might be more familiar with. But instead of reducing the dimensions to maximize the variability, we're reducing the dimensions to make sure that similarities and dissimilarities are preserved.
I didn't understand a word of that, but I'm trusting you, Thomas. Next question. This is our last one as well.
Hi, thank you. How susceptible is your methodology to the wider context? So two job descriptions looking for very similar people. One might say requires coding expertise, full stop. One might say requires coding expertise, e.g. Python, Stata, Fortran 77, I live in Hope, etc. And where they're not actually required skills?
Yeah, that's a great question. So it was asking how our approach deals with the different ways that people write job descriptions. So someone might say very explicitly, we want Python, but someone else might say we want programming languages and list R, Python, SQL. So at the minute, we're doing a very basic matching. So if it appears anywhere within the text, we would actually consider that to be one of the skills. So in that example with a list, all three of those programming languages would be picked out. So that is a limitation. But what we're hoping is that when we transition to using LLMs and generative AI, we can make sure that it ignores lists like that and even just generalize the skill a bit better. So maybe rather than having our studio being separate, it'll bring it together into a single R programming language. Yeah.
Thank you very much, Thomas. Thank you very much. Let's all give him a round of applause.
Thank you.
We're just going to pause for 5 minutes to allow people to move rooms. Those that want to go to other talks, and then my colleague Jenny Wood will be sharing.